Morning, everybody. Hey, welcome to Papa Lim Physics Classroom. Okay, today we'll be going through the exam paper for Sec 4 Normal Acad. Okay, on science physics. Okay, their prelim paper. The paper I'm using today is 2021 Holy Innocent High School. Okay, it's a good paper in the sense that it actually touched base with some of the small little concept that we tend to forget when we do our revisions. Okay, of course the question also covers the standard topics that are of interest to us. Okay, so but because of the fact that it touches base with the small section that we tend to miss out, so when we do this paper, right, it's actually a good test of whether have we completed a thorough revision for ourselves, okay, before the N-level paper. Okay, same as before, if you have not gotten the paper, you have not seen the paper, okay, you can download it from my Google Drive. The description in the Google Drive is in the URL link for the Google Drive is in the description video panel below. Okay, so you can just click on it and access the and download the file accordingly. For those who have done it, okay, I have left some of the URLs, some of the links for like certain concepts that we're using in the lesson also. So if you have not done, you miss out that particular topics or chapters, or you want to do a quick refresh on that chapter, you can click on the link, okay, to access the file. Okay, before we go on, okay, remember, if you want to get notification for any other new video that I will be uploading, okay, remember to subscribe to the channel, okay, and remember to press the bell button so that you get notification whenever I upload the video. All right, okay, now let's move on to the paper itself. Now for the paper, okay, okay, let's take a look. For those who have done it, okay, let me call out the answer first. Give me a minute. Now, for those who have done it, okay, the answer is here. Okay, you might want to pause the video here and to take a look at what are the topics that will be tested. What are the answers for the topics that are being tested? Okay, so you can pause the video and go and check your answer. For question 20, right? Question 20 was skipped because last year, this question 20, it happens to be practical electricity, which was the common last topic for that year. So it was removed. Okay, but for those who are doing the paper this year, okay, most likely the common last topic will be in. Okay, so for question 20, okay, okay, those who have done question 20, the answer should be D. Okay, delta. Okay, so take a look at it. Okay, we are dealing. Okay, we'll move on to the first question. Now, for the first question, I would say the first question revolves around the fact that the students will need to know one of the important aspects of vernier caliper is the range of vernier caliper. Okay, now in the space on the right side, actually I've called a range, a table on the, okay, that will illustrate the range of measurements, the range of the maximum, the range of the measurement for vernier caliper, micrometer, screw gauge, and even ruler. Okay, what are the possible range for use? What are the possible range that we should actually use vernier caliper, micrometer, screw gauge, or ruler, even ruler, to ensure the higher accuracy. Okay, so for vernier caliper, okay, remember the range that we are going to see for vernier caliper usually range from 1 cm to 12 cm. Maximum, I would say, is 15 cm. Okay, so usually it range from 12 cm. Okay, or maximum, I would say 15 cm for vernier caliper. So for items that usually be around this range, it would be ideal. Okay, ideal to actually use vernier caliper to ensure the higher accuracy. Yeah. So for among the item here, okay, among the items, okay, so students, you have to go through the item to check. Okay, length of test tube possible, okay, is to use vernier caliper, okay, is within that 12 cm range. Diameter of marble possible. Thickness of the metal block, okay, I will assume that the metal block may exceed 12 cm or 15 cm. So before we conclude D is not suitable or suitable, okay, let's do a question mark here first. Let's look at C first. Okay, so now C we're looking at is the circumference of the coin. Circumference of the coin. Remember what is circumference? Circumference is the perimeter of the circle. Okay, for perimeter of the circle is confirmed 100% that, okay, it cannot be measured using a vernier caliper. Maybe if I want to measure the diameter of the coin, yeah, possible, I can still use a vernier caliper, but confirmed circumference of the coin cannot be done using a vernier caliper. It's definitely a no-no. Okay, but as compared to thickness of the metal block, there is still a chance of possible using the metal caliper to measure thickness of the block, provided like I would say like the thickness of the block fall within 12 cm or 15 cm range. So it is still a possibility. But definitely for C, the circumference is confirmed a no-no. So in the sense that C and D, C will be a better answer, is confirmed a much better answer as compared to D. So that's why for this question number 1, okay, the correct answer I will choose is actually C, because C has the best fit for the question here. Okay, now, so for MCQ, take note, okay, MCQ, in the sense that all the MCQ choices, some of the MCQ choices given, they are actually correct answer, but just that maybe that particular answer, that option C or option D, okay, that particular answer that we need to choose is because it's a better fit as compared to the rest of the answer. Okay, in the sense that for MCQ, right, it might not be the case that you will actually see one correct answer and the rest of the 3 answer is a wrong answer. Okay, it could be a case, it could be another case whereby the four of them are actually correct answer, but just that one of them will be a better fit for the question. Okay, that's what we mean by choose the most appropriate answer for the MCQ question. Now, for conversion of the units, okay, conversion of units, I will leave I'll leave the conversion table on the right side of the video to highlight to students to remind you what are the prefixes that you need to take note. Okay, especially things like giga, micro, kilo, milli, deci, all these things. Okay, so all are the prefixes you need to take note. So if you know the prefixes, okay, having a D correct answer would not be an issue. Okay, so you should be able to arrive at A being the correct answer here. Now for question 3, micrometer screw gauge. Okay, micrometer screw gauge, remember the trick when we look at using micrometers question, it's not the trick is not about reading the micrometer correctly. That segment is over already. Okay, all students, you should know how to use a vernier caliper and micrometer screw gauge correctly. That is underlying a default thing that everybody must know. That's so I won't be testing you. It has to be done already. It has to be in your blood to know that micrometer reading the micrometer, reading the vernier caliper must be done correctly. But what usually the question will test you, okay, other than just reading the micrometer screw gauge, is actually they will actually need you to use the data to actually calculate other things. For example, in this question, the question asks you to state that the micrometer actually states the length of the solid cube. So we are looking at the cube. Okay, so the micrometer will actually give you the length of the cube here. But what I need to do is, after looking at the length of the cube, okay, what I need to do is actually I need you to use the length of the cube that you derive from micrometer screw gauge to actually calculate the volume. So what you need to do is we actually take the answer for micrometer screw gauge and we actually use it to calculate the formula for the cube, okay, which is the volume of the cube, which is L cube, L times L times L. Okay, so remember, other than reading the micrometer screw gauge, okay, take note of that you need to use the data for other calculation, other purpose. Okay, so important thing, the first base default thing is you must know how to read vernier caliper, micrometer, screw gauge correctly, 100% correctly. So if you have not done it, you have not revised that particular section, okay, I will leave the link for that video for micrometer, screw gauge in my description below, okay, even on the link on the top right hand corner, okay, so that you know where to find it. Okay, so if you have not done it, remember to go and do a refresher course, okay, to look at the video to see how to use vernier caliper correctly and micrometer screw gauge correctly, because that is the basis, or that is the basic of that particular topic. Okay, so if you have done this correctly, I will not. If you read micrometer correctly, okay, remember micrometer example, the common trick that we will not want to fall for it is to actually know that this number represent the above line represent the ones value, the below is the 0.5. So it's read as 0, 0.5, 1, 1.5, 2, 2.5, 3, 4.5, 3.5, 4, 4.5, and 5. Okay, so there is the ones is on the below, the 0.5 is on the ones is on the above, the 0.5 is at the below. So you must know how to read the micrometer screw gauge correctly. Now for question 4 is a classic example of using the acceleration formula, A equal to change in velocity, final minus initial divided by time. Okay, what is tricky about this is actually that the fact that the question says it is a deceleration. Oops, it's a deceleration. So which means by default, if it's a deceleration, you should be anticipating the answer for acceleration to be a negative number. Okay, so that is the answer that you should be looking at, is a negative number. Okay, so actually without doing any calculations, you already can derive an answer, because the option given is quite a distinct choice. Because I know it is a deceleration, so I will know that the answer for acceleration, if I use the calculator, okay, the answer I arrive for acceleration should be a negative number, which will represent deceleration. So among all the four options, the only option that is negative is only option C already. So the moment I know is deceleration, I know A is negative, and I know that C is the only negative answer, I will just choose C straight away. I will have 100%, I'm 100% confident that C is actually the correct answer, even without doing working. Okay, but on the other hand, if let's say you want to play safe, you want to do the working. Okay, so same thing, you can substitute the value inside the formula. 14 meter per second, okay, decelerate to 5 meter per second. So this will be the initial speed, U. This 5 meter per second will be the final velocity. So it will be a classic example of 5 minus 14 divided by 3. Okay, then after that, you will get the answer for your deceleration. It happens to be a negative number. Okay, it will be negative 3.0. Okay, so take note of the value here. Okay, so take note how you can do. Actually, there are simple tricks that we have to take note of so that you can actually proceed with your multiple choice question actually with like a grade, with a faster speed. Okay, with more grace and actually with more time on hand. Now, question 4 is a description for the graph. Okay, like I mentioned before, to describe the graph, okay, to describe a velocity time graph, when we look at description, we always describe what? We always describe, okay, the accelerations, okay, when we're looking at VT graph. And when we want to look at acceleration, what are the things that we look at? Okay, it's actually we are looking at the gradient of the VT graph. Okay, so in terms of description, okay, the technique of using the description is actually quite a standard one. Okay, whereby you look at we swing it from the perspective of the gradient of the velocity time graph, because the gradient of the velocity time graph is actually acceleration. So for example, if you know that the gradient for this horizontal line between 5 to 10 seconds is a straight line, so I will know that the gradient is actually 0. Indirectly, I'm actually also implying that because gradient is 0, it also means that the acceleration at this time segment here is also 0 meter per second square. Likewise, for the same for 15 to 20 seconds. Okay, so for 15 to 20 seconds, it will be at rest. Okay, it will be acceleration. Okay, the problem with this question is that because I know between 5 and 0 second, okay, it is 0 acceleration. Okay, so it's 0 acceleration. Okay, 0 acceleration has two meanings. Remember, 0 acceleration. Okay, it means it could be actually at rest, or it could actually means it's moving at constant velocity. The only way to actually decide which is the correct answer, whether it's at rest is the correct answer, or whether the object is moving at constant velocity is the correct answer, the only way to do it is, from my experience, is actually to look at the motion before it. Before the segment, okay, before A equal to 0, what is the object motion before it? Okay, so if the object motion before A equal to 0 meter per second square is not moving already, so now, when it is experiencing A equal to 0, it will still continue to have its motion, okay, which is actually stationary. Okay, so if before A equal to 0 meter per second, before it, he's already moving at a certain speed. So when A equal to 0 meter per second occur, okay, the acceleration occur, it will actually carry on with its previous motion, okay, which is constant velocity. And this, in fact, is actually what we know as your Newton's first law. Okay, so for this case here, we are looking at is the possible answers. We could be for 15 between these two segments, 5 to 10 seconds, 15 to 20 seconds. It could be at rest, because A equals 0 could be at rest. A equals 0 could also mean constant velocity, at rest, or constant velocity. Okay, so in fact, if you look at the aspect, A equals 0, all the four choices is possible one. But then on close examination, let's say for example 5 to 10 seconds. Okay, on 5 to 10 seconds, we know that beforehand, maybe at 4.8 seconds or maybe at 4 seconds, the object is already moving already. He's already moving at a certain speed, 3.8 meter per second, 4 meter per second. Okay, it's actually moving already. So which means the previous motion at before 5 seconds, he's already moving. So when A equal to 0 meter per second square occur, because previously he was already moving, so it implies that at this motion between 5 to 10 seconds, he will not be stationary. because the previous motion is already moving at a certain speed. So what is the next motion when A equal to 0 meter per second occur? He will actually be moving at a constant speed. So which is why I know that this option A is out. Option C is out. Okay, and from here, you will actually know that I actually can eliminate option A and option C already. And likewise, same as before, okay, at 15 seconds to 20 seconds here. At 15 seconds, so I look at the motion before it, maybe 14.8 seconds or 14 seconds, he is already moving at a certain speed. So which means he is already moving before that. So which means that he will not be at the previous motion he's doing is he's already moving. So he will, the instance when A equal to 0 meter per second square set in, the previous motion is already moving, which means that at 15 to 20 seconds, this interval, he will not be at rest one. He will continue his last motion, which is still moving. So which is why, okay, option A is out. Okay, zero acceleration is possible. Okay, zero acceleration is possible. Constant speed is possible. So from here, we have actually eliminated A. We have also eliminated C. Okay, so you only now left with B and D. Okay, so now for, let's say for 10 to 15 meter per second, 10 to 15 meter per second, you look at it, okay, the speed is coming down. The gradient is actually a negative number. Okay, it's a negative number. So this will imply when you have a negative gradient, it will imply this motion is actually having a deceleration. Okay, so negative gradient, it will imply deceleration. So which means, okay, at 10 to 15 seconds, this interval, the object, okay, the girl is actually experiencing a deceleration, a uniform deceleration. The only, for 10 to 15 seconds, okay, the only option that is not eliminated and has uniform as a deceleration is only option B. Okay, so from here, I can actually safely conclude that actually B is my only correct answer. Okay, based on the inference from all the different segments of the graph. Okay, so from here, I will know that the answer for this particular question will be B. Okay, the thinking process here I'm using it, or the technique I'm using is actually is really the basic of BT graph. Velocity time graph, when you look at velocity time graph, we are looking at two important things. One is the gradient, which represents acceleration. Then after that, we look, the other important thing we using for velocity time graph is the area under it, because the area under velocity time graph represents distance. Okay, for gradient, okay, remember especially when we're looking at gradient, when we're looking at acceleration, the important thing, I would say the tricky part is actually dealing with A equal to 0. Although A equal to 0, there is a high chance that it is in, let's say in your structural question, there's a very high chance when we say A equal to 0, it usually means constant velocity, usually. Okay, but there is still a chance that it could be stationary. So we cannot just blanket everything, say, oh, whenever I say A equal to 0, it means constant velocity. No, we cannot blanket it. We still need to do a test to check whether the object is stationary or whether the object is moving at constant speed. So the check, to identify the motion is actually very, very important. Okay, so if you're still quite confused about this particular section, okay, you can actually pause the video and rewind back to like the previous, like 10 seconds ago to see how I actually derived the motion for time 5 to 10 seconds and 15 to 20 seconds, these two intervals. Okay, now for question 6, okay, if you're looking at question 6, it will be on forces, a classic Newton's law motion, F net equal to ma. But what happens when you have two forces, one is 5, one is 20? Okay, you'll find that the resultant force will actually be a 20 minus 5, and the resultant force will be 15 Newton. Okay, so this will be 15 Newton. The net force will be 15 Newton to the right. Okay, we imply that it will also means that because it's a 15 Newton, okay, it will means that if you look at the math, it will means that the acceleration is definitely a positive number. Okay, when A is positive, it is 100%, it only may have one meaning, it will mean that the velocity of the object will definitely increase. Okay, or what we call, it will definitely have an acceleration if the speed will increase. Okay, maybe at whatever rate, depends on the question, but I know that from now, when I say the Newton, when we work out the fact that it has a resultant force 15 Newton, the first inference I can definitely make is that the direction of the acceleration or the direction of the net force is pointing to the right, and it definitely has an acceleration. Okay, and the acceleration based on the question is a positive number. Okay, so I would say that the object is definitely experience what we call a constant acceleration. Okay, because based on the math, okay, I can actually do a first line inference to say that, to know that the acceleration is definitely a positive number. Okay, and from there I can conclude it is actually having a positive acceleration, or what we call a constant acceleration. Question 7, okay, the classic example of mass weight density. Okay, when on moon and on Earth, okay, remember when the difference between Earth and moon is actually the gravitational field strength. Okay, gravitational field strength on Earth is 10 Newton per kg. Gravitational field strength on moon, we do not need you to remember the student. We don't need students to remember the gravitational field strength. What's the number? But we need students to know that the strength of the field strength on the moon and on Earth, the magnitude is in terms that the Earth is definitely greater than moon. Okay, so let's say the gravitational field strength on moon is 1.6 Newton per kg. Okay, so we do not need to know it's 1.6. If you need, I will give you one. Okay, but usually what we need students to know is to understand that the field strength on moon is actually smaller than Earth. That's the basic. Okay, so, and here we can conclude because of the difference in strength, the weight of the object on Earth will be actually larger than the weight of the same object on moon. Okay, because why? Weight is mg. Okay, weight is mg, and because of different gravitational field strength, the weight of the same object, same mass, okay, will actually be different. Okay, so that's why we can actually safely conclude that actually, because of the weight difference, he is able to jump higher. Okay, because of the difference in weight. Okay, so take note of the question that is trying to question is trying to test. Okay, on the difference in the gravitational strength, which affects the magnitude of the weight and indirectly affects how high you jump. Now, question 8. Question 8, I will not dwell too much. It's a classic example of using the formula density. Okay, equal to mass over volume. So identifying the correct mass. Okay, 30 cm 100 gram before that. Okay, after that, when the ball is placed, this will be 80 gram. There's an 80 gram increment. So I will actually know that the mass of the ball is actually 80 gram. Same thing, volume of the ball before I put, okay, there's a 30 cm mark. After I place the ball inside, it's a 40 cm mark. So the increment is actually a 10 cm mark. And the 10 cm increment is actually the volume of the ball. And straight away, if you do the math, you will know that the answer would arrive is 8 gram per cm cube. That will be the density of the ball itself. This method that we're using is what we call a displacement method. Okay, to identify the mass of the volume and the mass and the volume, to identify the mass and the volume of the ball. Okay, of unknown shapes, basically, that can sink. Okay, now the lamina, the flat lamina, this question is quite a famous question in the sense that it always is a famous question. It is a common question. It's a quite unique, but yet it's commonly tested. Okay, it's available in the previous N level paper and even the O level paper. Okay, now based on the question, the weight of the object is lamina is at N and the CG is at C. These two statements, weight and CG, it will tell you that the weight of the object, which is 2 Newton, it occurs at C. Okay, so this is the weight of the object, which is 2 Newton. It occurs at C, pointing downwards. Okay, so if you look at it, and based on the question is the pivot, the pivot is at P. So this is where the pivot is. The pin is here, so the pivot. Okay, so I'm looking at the moment. So if I have the force, the weight is pointing at C, is moving downward. So the line of action will be here. So if you look at the perpendicular distance, it will be between these two lines. So this will be the perpendicular distance, what we call dw. Okay, so dw will be what we call QC, will be 0.3 meter. And you know that because the pivot is on the left side, okay, the weight is on the right side, you will know that the moments created by the 2 Newton about the pivot is actually a clockwise moment. Okay, so which means moment of the weight will be the weight, which is the force, multiplied by the distance. The perpendicular distance will be dw. Okay, so it will be 2 Newton multiplied by 0.3 meter. Straight away, you will know it will be 0.6. And you know that the force, the moments of the object is actually clockwise. So this will be the answer, option A for question 9. Okay, so identifying the perpendicular distance is utmost important here. Okay, to know what is the or where is the perpendicular distance. Okay, I've actually gone through the technique of using it. If you have forgotten about it, okay, I will leave the link in the description panel below, and I also activate the link on the top right hand corner of the video, okay, so that you can actually look at it. Okay, do a short refresher course or identify on how to identify perpendicular distance. Okay, it's a interesting but yet important technique that we interesting and important technique that we need to know, especially for MCQ and structure question. Okay. Oh, this is the okay. The question is here. Let me take. Sorry, yeah. So the question is there's a hydraulic. It's a closing here. So this is a hydraulic press. Okay. So what we have here is hydraulic press in the sense that when A1 position A1, the force is pressing downwards. Okay, this force, okay, to push the whatever liquid is inside down, and indirectly the liquid on the right side will actually be pushed up. And indirectly, when I push up, okay, the lorry or the lorry, is it? The trailer will actually be shifted upwards. Okay. Now, so what happens is when we shift upwards, okay, this force that's applying, it will be the same magnitude as F2, or sometimes what we call the weight of the object. Okay, the weight of the object. Okay, so the two forces must balance. So in the sense that based on the question, the weight on the trailer on the right side is actually 20 kilonewton. Okay, so this is the force F2. Okay, the area is given respectively 0.10 and 0.5. So this is 0.10. This is, sorry, not 0.10. It's 10 meter. 10 meter square is a big surface. Okay, and the other side will be 0.5 meter square. Okay, so now the important thing about hydraulic press, okay, is remember is because of the fact that the water or the liquid is incompressible. And when the liquid is incompressible, okay, one of the interesting fact is that arise is because it's being incompressible, the pressure exerted at different part of the liquid is actually transferable, or what we call is actually remains the same. Okay, so indirectly we are saying that the pressure that occur at the left side, okay, the pressure, I will label this as P1, it will actually be the same as the pressure that is occurring and on the right side here, or what I will label is at P2. Okay, because of the fact that the liquid is incompressible, pressure is actually transmissible, okay, 100%. So we can actually conclude that P1 is actually equal to P2. This is the what we call the hydraulic equation. Okay, so P1 equal to P2. If you break it down for pressure, for at the right side, P2, it will be consistent of F2 divided by A2. Similarly, for pressure 1 on the left side, it will be, if you break it down, it will be F1 over A1. Okay, and based on the question, if you look at the math, F2 is 20,000 Newton. Okay, A2 is 10 meters squared. On the left side, F1 is unknown, which is what you need to find. Okay, then area given will be 0.5 meters squared. Okay, so if you look at it, you will arrive at a simple algebra equation. Okay, so you can just do your cross multiplications, all this, and you can actually identify what is F1. Okay, and if you press your calculator, you'll find that the answer given will be 1,000 Newton, which is option B. Okay, so the important, if you look at the math behind hydraulic press, it all started with one thing, okay, which is pressure remaining the same because water is incompressible. It all started from here. So I would say there's no need to memorize any formula. Just look at the basic of pressure formula. The important thing is to know that the concept of liquid, why I use liquid is because it is incompressible, and because it's incompressible, it allows me to actually transfer the pressure, okay, whereby the pressure actually remains the same at all sides. And from there, I can actually work out whatever equations I need. Okay, that's what we mean by understand the base, understand the concept, understand the fundamental. Don't just memorize. Okay, question 11. Okay, the meteoroid, okay, enter the Earth, okay, and he traveled a distance of 99 meters. And what is the approximate work done? Work done is what we call force times distance moved in the same direction, okay, or what we call the same axis. The distance moved is 99 meter. Oh, that's straightforward. This one I would say everybody can identify. But what we tend to forget is that force has to be Newton. And what is given to us is actually 10 kg. 10 kg is mass. Okay, so mass is definitely not force yet. So for mass to become for force, okay, what we need is we need to convert 10 kg to what we know as your 100 Newton. Okay, using the formula weight equal to mg. Okay, so I will not dwell too much. This should be straightforward for you. Okay, so force is 100 Newton. Your distance moved is 99 meter. And with that, if you look at the multiplication, you will derive at the answer that C would be the answer here. Okay, here the important thing about work done is, remember, work done we're looking at forces. Okay, forces and distance. Okay, so distance, the first trick that we always remind students, the first important factor about work done is that the distance has to be in the same axis or same direction as the force. I always remind students it's in the same axis. Okay, so and also the second factor we always need to know is that the fact that there is a force at play. A force here, so which means the force I need is definitely, it has to be Newton. So sometimes if I give you kg and if the force happen to be weight, remember to make a small step, one more steps to actually convert the mass kg to a force, which is weight in Newton. Okay, question 12, kinetic energy versus temperature, what we call the thermal property. Kinetic energy is actually related to your proportion to your temperature. So this two is a proportion thing. So when you're doing a revision for thermal property, this, I would say this is something that you will come across quite common, quite a lot of time. Okay, quite a lot of time. Okay, so in fact that whenever temperature increase, what is the cause of it? Is primary reason is actually because of the fact that the kinetic energy increases. That is confirmed the first line of direct inference. Okay, whether the space increase, whether no. Okay, the moment you know that, the moment we understand that temperature is pegged directly to kinetic energy, and the moment you actually see the question, you see the option A, first one, average kinetic increase, yes, increase, and their proportional increase, temperature increase kinetic energy. Well, the moment you land your answer there, option A, you choose it straight away. Okay, which you confirm it is always the correct answer. Okay, question 13. 13 is the convection current. Where should be heater? Where should the heater be to have the convection current of what we call hot rise cold sink? Okay, so this one I would say is a basic question that we always see in your Sec 1 and Sec 2, what we call your year 7 and year 8. Okay, so I will not dwell too much on this question. I'm fairly confident that when like all the viewer here will be actually be able to do this correctly. Okay, now 14. Now 14 here is there are three scenarios. Okay, now question, the first one is you're looking at the start. Okay, where the start experiment is everything is ice. At the end of the 15 minutes, okay, most of it is actually melted. Okay, but some of the ice is actually still visible. It's most of the ice, not all. Some, okay, most or some. Okay, some of the ice is still visible, or what we call most of the water has, most of the ice has melted most. Okay, here what we are looking at is that we need to know that at the start of experiments, okay, the ice is still the ice has not melted. So which means what we call the melting process actually has not occurred yet. Melting process occur when? Melting process occur when the solid object actually starts to turn to liquid. The moment I have the first drop or first few drops of liquid appearing, yes, I am very confident that melting has occurred. So melting actually occurred where? Melting started at 5 seconds, after 5 minutes, sorry, not 5 seconds, 5 minutes, whereby I see a bit of water appearing. This is the sign to tell us that actually melting has started. So which means melting phase is actually started at 5 seconds. So it should be a horizontal line beyond 5 seconds. So definitely because of that, I know that B is out. Maybe there's no horizontal line here. Okay, I know C will be out because there's no horizontal line. D is possible because there's a horizontal line to indicate melting has started. Now, what is important is after that, after 15 minutes, especially this statement and the picture, after 15 minutes, some ice is still visible. Okay, when we say some ice is still visible, it actually gives us an indication to say that melting has not been completed. Melting is completed when there is totally no ice at all, when all the solid actually converted to liquid already. So when there is still a bit of solid, no matter how small it is, how small the amount is, melting has not ended. So after 15 seconds or at 15 seconds, I am very confident or we are very sure that actually melting has not occurred, has not completed yet. Okay, so melting is still ongoing. So it could be finished melting. So whatever remaining ice here, it could be maybe finished melting, it will disappear, it will turn to liquid, maybe at 17 seconds, but definitely not 15 seconds, not less than that, not even at 15 seconds. So which is why I'm saying fairly confident that at 15 seconds it is still a horizontal line, which will indicate that actually D is wrong, because D already says that at 10 seconds, melting has stopped, and actually at 10 seconds or 10 minutes onwards, okay, all the liquid has actually been heated up. Actually, it's getting hotter and hotter already. So which means it has an indication to say that at 10 seconds, the container should be containing only 100% liquid, which is not true, because based on the question at 15 minutes, okay, interval, the beaker still consists of a bit of ice. Okay, so that's why I would say D is definitely out. So BA will definitely be the correct answer, which indicates the essence of what we call melting, when melting starts and when melting stops. Okay, so this I would say is a very good question to say to see how the heating curve actually is being represented, not just in graph, but in terms of picture, a pictorial representation of how melting occurs, which is quite good. Okay, quite interesting. Okay, 15, the ripple, the wave, all these things. We look at the wave graph, we have two graphs, displacement time and displacement distance and displacement time. The same thing, the moment I always tell students, the moment you see these two graphs, the first thing you look at is actually to identify the one cycle. Okay, because the one cycle on each graph, although they represent the same wave, the one cycle actually represent different information. For example, one cycle on the displacement distance graph here actually represent the wavelength. Displacement time graph, the one cycle here actually represent the periods. Okay, of course, you know that from period, I can actually deduce frequency. So I'm fairly sure that if you know that, you will know that the period for one cycle, it will be 0.04 seconds. The wavelength at one cycle, it will be 2 cm here. And the question here is they look at the speed of the wave. So speed of the wave, the only one formula for wave formula is V equal F lambda. Okay, lambda, I have it, which is here. Okay, so now I need to take one step further to calculate the period. Okay, so I use the period to calculate the frequency, which implies that frequency is actually 1 over T. It will be 1 over 0.04. Okay, in hertz. Okay, so if you substitute this number into the equation, you will give us 1 over 0.04 multiplied by wavelength, which is 2. You will arrive at the answer. Okay, so it will be, if you look at the calculator, okay, you'll find that by pressing the calculator, you get the answer to be 50 cm per second. Okay, which is the speed of the wave itself. So this is a classic example of using how we actually use the graph to actually deduce different information. And after that, we unify the factors that we have or the information that we get by using the wave formula. Okay, V equal F lambda to get what we need. Okay, so now for question 16, it deal with EM spectrum, whereby every time I always tell students, okay, we always for EM spectrum, okay, always remember for EM, okay, always remember the wavelength of the component of EM and the frequency of the components. Okay, your gamma ray, X-ray, ultraviolet ray, radio wave, microwave, all these waves, all these components. Okay, take a look, know their arrangement in terms of whether they are arranging in increasing order of wavelength or increasing order of frequency. After that, always remember their users, know their users, be aware of their users. Okay, and sometimes you need to be aware of their advantage and disadvantage, what we call the pro and cons. Yeah, and with that, you should be able to do question 16 quite easily, especially with the use of gamma ray. Gamma ray, okay, one purpose is actually to kill cancer cell. Okay, nobody use it for sun tanning. After you get cancer straight away. Okay, so 16, I would say it's quite straightforward. Now, question 17 is I would say it's an interesting way of representation. It's compared to question 15, okay, whereby they use the graph, displacement time graph to represent wavelength, okay, in this case. Okay, now what happened is I use the ripple, the actual wave itself, to represent the wavelength. For example, based on the wave, this is the wave, this is the cross-sectional of the wave. Between the crest and crest, it actually means there is actually, between crest and crest, we all know is wavelength. But when we look at it at the top view of the wave itself, you see this crest. This is the top view of the water wave. Okay, of the wave itself. The cross-section, like we say, the cross-section, it means the side view of the wave. So if you look at it, right, you'll find that PQ, it could easily means here. Example, this could be represented by PQ if you look from the top. Okay, so if you look from the top, let me use a different color. So if let's say if I use a blue one. So if I look from the top, this will be P, this will be Q. If I look from the top, okay, look down, okay, this will be P, this will be Q. Sorry, not P and Q. This will be the 2 point I'm talking about, not P, sorry, wrong label. So here. So this is Y, this point will be X. So if I look from top view, this point will be X, this point will be Y. Okay, so this is what we call the crest. So you look from top view, you only see the crest, okay, and that crest corresponds to the side view of the crest. So between X, Y is what we call your P, your wavelength. So in the sense that we all know that between crest to crest is actually the wavelength, and from the top view, it actually means that all this distance between is actually called your P, is all what we call your wavelength. Okay, so in the sense that your wavelength is actually between the crest to crest is actually represented by P. Okay, so wavelength is represented by P. Wavefront in the sense that you only see wavefront from, is the most obvious one is from the top view. Wavefront actually connects all the crests together. So when we say the X is the crest, we are also saying that actually all sections here are all crests. Many crests. So when all the crests actually put together side by side, they actually form a straight line. The straight line or that line that we call is actually called wavefront. This line that connect all the crests together is actually what we call your wavefront. So that's why we know that R is actually known as your wavefront. Okay, I would say it's an alternate representation of wave and wavelength, waves, and actually wavefronts. Okay, so that's why option is A. Okay, I would say it's good. It's a good thing because we tend to forget what is wavefront when we do our revision. Okay, so this is a timely reminder of what it's like to know what is wavefront. Question 18. Okay, charges. The formula that we're looking at will be I equal to QT. Okay, I equal to QT. This is the formula. The only thing I like to highlight to students, I would say that most of us, if you remember the formula, doing these questions should be quite straightforward, just applying the formula. But one of the booby traps that we lay down here is actually the use of SI units. Here is milliseconds. Okay, remember in SI unit, current is ampere. The unit for charge will be coulomb, and T has to be in SI unit, it has to be in seconds. Okay, so if it's 10 milliseconds, it's not seconds, it's milliseconds. So it will be actually 10 millisecond is actually 10 to the power of -3 seconds. Okay, so you have to divide by 1000. So it will be actually equivalent to 0.10 seconds. Okay, so time you need to substitute not 10, you have to substitute 0.10 inside the time. After that, you use a calculator, you get the answer straight away. So you look at it in terms of math, it will be current is equal to Q, which is 25 coulomb. Time will be 0.10 seconds. And that will be the answer for the question here. Okay, which is D. Okay, so this will be the answer here. Now, so far, take a look. This is the I equal to QT is a very common formula that we quote from students. But take note, this formula is wrong. This formula that my students always quote I equal to QT is wrong formula. This formula is wrong. Okay, don't mix up. Okay, formula most important. Please remember the correct formula. The formula for current is actually derived as I is equal to Q over T. Okay, remember the formula. Okay, current is formula is Q divided by time, not Q times time. Okay. Some of my students, they actually always like to write this. I don't know why. Okay, just for like convenient or something like that. Okay, so but it's the wrong formula. So current should be, okay, Q divided by time. Q should be 25 coulomb. Time will be 0.10, okay, seconds. So if after that, you'll find that the answer will be 25, okay, 2500 ampere, okay, which is option D. Okay, so please take note, this is the correct answer. This is the correct one. Okay, this is the correct one. Okay, so remember the correct formula. Okay, formulas, okay, is the basic of your, is one of the basic factor of your physics. Okay, so you cannot remember the wrong formula. Okay, so take note of the formula representations. 19, okay, connected wires. Okay, the wires are actually usually thick based on the question. Okay, now here we use the basic formula for resistance, R equal to rho L over A. When the thick wire here actually represent the area is big. Okay, the area of this is big. The area, the cross-sectional area is big, aka the denominator for this formula is actually very large, or what we call, because I'm using a thick cable, okay, the resistance of the cable actually will be low. And when the resistance of the cable is low, okay, when the cable is low, what is the impact? Okay, what will be the impact? Okay, resistance is low, or what we call your impact will be the current will be high. And true enough, is some hi-fi stereo systems, all these amplifier, all these, they actually require quite high current, or what we call sensitive high and sensitive current. They are sensitive to current, and they actually require high working current. So that's why the current has to be high. And to do that, actually the cable has to be of a certain thickness, or what we call the resistance has to be of a certain value. It has to be quite a low value. So in fact, okay, so once you derive this, you actually know that C will be the correct answer. Okay, because based on the thickness, okay, thick cable, usually we have very, okay, low current. And because low current, I can actually transmit high current in the cable for the system. Okay, 20, fuse melt. Okay, I would say it's quite straightforward. It's a straightforward answer. Okay, fuse. Okay, the function of fuse is when melt, when it is too large. Remember keywords. Don't just choose the word melt. Okay, you remember the other keyword to make this statement correct is because the current has to be too large. Okay, sometimes the question never mention it. Sometimes the question will just say, oh, it will melt because the current is a normal current. No, it's not a normal current. Fuse is to actually, it's a safety function that will actually will actually protect the appliances and the user when the current in the circuit is actually higher than expected. Okay, it has to be higher. Okay, all right. So this will be the end of our paper 1 in the MCQ. Okay, so now we will move on to paper 2. Okay, paper 2 is a 14-mark question. Okay, now stability, give reasons for the stability. Which car is more stable? Okay, by this you should know. Okay, the sports car is famous for their stability because of two things. Okay, because of the fact that their base is large, they have a broad base, broader than most of the car. Okay, and the other factor is because they are low, they are actually much lower. They are very, the driver actually sit very close to the ground. They have to be kept low because when they are low, their CG, okay, is low. Okay, and when you have broad base, when you have large base area or broad base, when you have low CG, okay, they actually contribute to the stability of the system. So the lower the base, the lower the CG, the broader is the base. Okay, the more stable you are at when you are driving. Just the more stable your car is. Okay, so you provide stability to the car, especially the sports car, whereby it's traveling at high speed, so it will not crash so easily. Now, both cars have the same mass. Okay, suggest why the stationary sports car exert less pressure. Okay, pressure, the formula that we're looking at is force over area, force per unit area. And when the question says, okay, when the question says same mass, the word same mass implies based on the formula for pressure, you actually give information regarding the force, which is what we call weight. Okay, I need same weight. Same mass implies same weight. So the only factor that affects pressure, okay, other than the weight, it has to be the area. So the contact area, the perpendicular contact area will be different. Okay, and based on the question is that for us to have a lesser pressure, it will mean that the contact area, or what we call the large base area, means that it has a larger contact area. Okay, and true enough, okay, sports car has a larger contact area. Why? Because it has a large base area. Okay, large base area, or sometimes I will always encourage students, instead of using large base area, it could be large perpendicular contact area or perpendicular area. Okay, given that the pressure is always, then after that, you will state that the pressure will actually change, will actually be affected. Okay, so now when we look at the question here, other than identifying the pressure is less, okay, what are the keywords that is needed to write? Okay, so one of the techniques that I always encourage students is actually write your answer like using the formula as a guide. Based on the formula, you have a mention of force and you have mention of area. So which means in your structure of in structuring your answer, you should actually mention the force itself. You should actually mention the area itself. So you should be looking at these two factors. Okay. Then after that, you conclude the pressure. So how I will craft my answer is I will actually use the formula as a guide. So the formula has F. So I have to mention in my answer, I have to mention it about the force. And true enough, the question say that they have the same forces, or what you call they have the same weights. Okay, so my answer, I would definitely include the use of the word first, same weight. And also because of the fact that the second factor that deal with is the contact area. So one of the keywords that I will encourage students to use is in your answer to craft it, to use the word contact area, or what we call perpendicular area. So I always like to use perpendicular area. And based on this question is because sports car has a large base area, it will imply, okay, having a large perpendicular area. Okay, so in the sense that in my answer, although it's a bit long, okay, in my answer, I will actually make sure that I actually includes the first keyword, same weight, and second keyword, large base area, or what we call a large perpendicular area. Then after that, we will most of us, we will actually straight away to conclude that the pressure of the object actually is smaller, okay, or lesser. Now, here, one thing I would like to caution you is that when we use the formula as a guide, one of the things that we always tend to forget, okay, is that the formula doesn't just mention P, F, and A, pressure, force, area. There is also a mention that there is also a segment that we tend to miss out. There is actually a division sign here. Okay, so we actually have to make sure that we tell the marker that actually we know it's actually force divided by area. And how do we tell the marker in terms of wording? Is actually to use the word what we call, since pressure is force per unit area. Okay, oh, sorry for my handwriting. Okay, let me write again. It's force per unit area. Okay, then after that, I conclude pressure of the sports car is actually lesser. So why do I want to write this red color word? Okay, this red color here will imply the use of the word division or divides. Remember, we will not want to use the word divide or division, because divide division is a mathematical treatment for it. But what the question wants is explanations. So in terms of explanation to explain division, we always like to use the word force per unit area to tell the marker that we as a students, we actually know is force divided by area. Okay, so when we look at the formula, we don't just look at the factor that we are looking, we don't just look at P, F, and A. We also look at things like what? Division, product, multiplications. Okay, the product multiplications, okay, or division per unit. Okay, whenever we divide, we always have to use the word per unit to indicate the marker that, hey, I know these two factors, F and A, and I know how they are related. They are actually related by per unit area, division. Then I can safely conclude that the pressure is actually lesser. So if you craft your statement this way, if you craft your answer this way, you can actually guide the marker, okay, on your thinking of or your using of the concept pressure. Guide them down to tell them that you actually know the concept and you know how to apply them 100% without any benefit of the doubt. And once you have done that, the marker will be very 100% convinced that you know what you're doing, and they actually will award the full marks for you. Okay, so that's why one of the key things that I always tell students is actually use the formula, not just for calculation, as you use it as a guide for your writing of your answer, for crafting of your keywords. Okay, your calculation and your formulas, your calculation and the explanation, the writing, the wordings, actually they are complementary each other. They are not separate. They are not separate things. Okay, they complement, they guide you in your guiding of your answers. Okay, question 2. Okay, energy. Okay, conservation of energy. I will not dwell too much. Okay, definition. Okay, I will say most of you should know and must know the definitions. Okay, calculation of the speed of the ball at y. Okay, now in the ideal situation at x, this will be where I have all my potential energy, and at y, it will be the lowest, so it will be all the energy will be converted from EP to EK 100%. So I will say it's not nothing fanciful. Okay, I will know it's only EP to EK because the question says it's a frictionless track, so there isn't any heat loss at this surface here. So it's 100% conversion EP to EK. So that's why I can use the formula. Okay, half mv square equal to mgh. You should get the answer out quite easily, quite elegantly, in fact. Now, after the question says that when I pass through point Y, it has a rough surface. Now, keywords, take note, rough, it means there is friction. Okay, if you look at it in terms of energy, there is work done due to friction. Okay, remember, there's a losses. Okay, so given that the friction is 30 Newton, here we go. Okay, what is the horizontal distance that it takes for it to take a complete stop? So which means from Y here, okay, if you stop, it will mean that the EK is 0. So which means where does the energy from EK, from Y, it convert to? Okay, there's only one thing based on the question, because there is friction along the way, the energy converted will be given to the work done, will be lost as heat loss, between the surface due to the friction, or what we call work done by the friction. Okay, so that's why the kinetic energy will be 100% converted to the work done against friction. So that's why my half mv squared, okay, will be converted to work done, which is force times distance. The force given is 30 Newton. Distance d, okay, which is what I need to find. Okay, you apply the calculation, you should be able to get an answer as 1.6 meter. Okay, what we mean by energy conversion. Okay, track the energy. Look at how I do it. Okay, not just the formula. It's whenever I tell my students that energy is not just looking at the formula, it's the technique of using it. The technique that I always tell myself to do is before I start the question, I actually will write down what are the energies is available at the point. For example, EP at X, I know the energy available is only at potential energy. So I'll write down the energy. At Y, I'll know the energy is only EK. And at Z, I know it is work done. So once before I start, I actually label down all the energies. Because why do I want to label down? I want to label it because the labeling will actually tell me what energy, and it also indirectly tell me what is the conversion like. And once I know the conversion is being done, okay, I actually know the math already, because conservation of energy states that energy has to be converted, okay, from one form to another, and aka with the correct type of energy at each position, I can actually form correct equations between the 2 points here, like what I did for part B and part C. Okay, the equation between the point, okay, so that I can actually use algebra to solve it later. Now, question 3 is a heat sink. Typical heat sink, I will usually say is more for conduct convect radiation question. Okay, so let's take a look. Okay, kinetic theory, change in motion as it gains heat from the computer. Heat sink, it means this is a solid. Okay, it's a solid. Okay, same thing, solid means solid. The only thing when we talk about solid, when we talk about state of matter, the kinetic theory is solid. The particle is actually bounded at its position. What it does is it only vibrate at its fixed position. So when I gain kinetic energy, okay, it will mean I will actually vibrate. Remember, keyword vibrate at fixed position, okay, and faster rates. Okay, so you link all this together, you'll know that the highlighted yellow one will be the one that you need to write. You write down. So that will be the keywords to tell the marker. Okay, so here what we emphasize the fact that you have to write vibrate at fixed position, because if you just write vibrate faster, right? The marker will not be able to distinguish whether are you talking about liquid or are you talking about the state solid, because solid and liquid, both of them actually vibrates, okay, faster. So there's no clear indication whether the students know that it's actually a solid that the question is referring to. So that's why I need students to use the word fixed position to tell the marker that it's actually a solid that we are looking at. Now, the other aspect would be the second question, whereby they look at what other feature of the hissing. Okay, when you look at the feature, we are looking at the shape or the size or even the the color, if you can see. Okay, so in terms of the structure, okay, the structure of the hissing, okay, you are looking at like you have this, there are multiple spacing between them, okay, and the fact that the hissing is made of metal. Okay, so all these contribute to different purposes. Okay, for example, okay, the rate is made of metal. Okay, implies that it's metal, is a good conductor. I need to conduct heat away from the processor fast enough. And if you can see the color, if it's printed in black for your exam paper, you'll know that it's actually printed black. Why? Because black is a good emitter of heat. So the moment the heat sink actually absorb the heat from the processor, okay, from the computer motherboard, all these things, what I need to do is the heat sink, the purpose is actually to absorb the heat and actually to distribute the heat to the environment so that I can actually lose heat to the environment fast enough so that I can cool down the system, where I can cool down the computer. So black is actually one of the desired color. Same thing also that you'll find that the radar has what we call small plates, okay, or what we call, sometimes you don't write small plate, you tend to write small fins. Okay, so you have fins between them. These are the area that we say fins. These small things are fins. Okay, instead of a big, gigantic rectangular block, I actually want to cut it into, actually want the shape of the heatsink to be in terms of fins, like this thing, like this, what you're seeing now. They're small, like spikes, okay, poking up from the heatsink. Why do I want it to be in this spike form or this fin form? Is because of the area. Because when it's in fin form, you find that this area, I have more areas exposed to air. And because I'm exposed to air, right, I have more area that's exposed to air. It allows me to actually radiate heat at a faster rate because the contact area is actually increases. If I have if I have only one block of solid metal, right, I'm looking only at the front, left, right, up, down surfaces that is in contact with the area. But then if I have many fins, okay, what I'm looking at is every small fins, I have like 4 or 5 contact area. I have 60 fins, I have 30 fins. I'm looking at 60, 30 times whatever contact area. So if you're looking at fins design, you'll find that the surface area that is in contact with the air is actually much larger than a block of like a block of metal. And because I have a large surface area, it actually allows me to actually radiate heat at a faster rate in this case. Okay. Now, suggest what happened. Okay, suggest what happened. Okay, based on part C, they say suggest I spring some water. Okay, at room temperature, allow it to cool faster. Okay. Of course, the assumption here is when I sprinkle water, it doesn't affect the circuit board. So let's say I spring the water only on the heatsink. If I sprinkle on heatsink, it's actually a good choice because when I sprinkle the water, okay, water on top, what water does is it actually allows with water, okay, there will be evaporation. There will be evaporation on the surface of the heatsink. Okay. So now what happened is with the evaporation ongoing, okay, what happened is, why do I want evaporation to occur? Because evaporation, okay, one of the function of evaporation is that evaporation has a cooling effect. It has a cooling effect. And because of this cooling effect, it will actually helps to actually cool down, okay, the computer. Okay, that's why when Keegan actually wants to sprinkle some water on the heatsink, it actually is a good option. Actually, we should. He is actually doing what he's doing what is needed, which is the correct method. Because why? Because with water, it allows evaporation to occur, and because when evaporation occur, it has a cooling effect, and it does help to lower the temperature of the heatsink. Okay, with this, okay, section A is done, and we move on to section B, whereby one thing I like to highlight again and again is actually don't answer the question first. At section B, please read the question first. Please read all the 3 questions. After that, choose the correct question or choose your best 2 questions. The 2 best, aka what we call the two questions that allow you to get the most mark here. Okay, so now let's look at question 4. Question 4 here, right? Okay, is a question on kinematics. So I think it's the usual approach or the usual pattern that the question have. They will give the data, then your objective is, I think, to plot the data. So the important thing is actually to plot correctly. See the data, see the numbers, and plot the graph correctly. After that, you join them using a straight line. Now, when you draw the speed time graph, right, I think plotting shouldn't be a problem. But when the moment we activate speed time graph, things to take note is when you look at axis. Okay, when axis, especially for time. Okay, if they give you in minutes, right? Okay, remember later on in your working or in your formula, all these things, remember to convert the minute to seconds. Because most of the time when we look at kinematics, the formula that we use is always in SI units. So if it's minutes, if it's hour, remember to change it to seconds. The second thing we want to take note is that when we look at your speed time graph, things that we of important to us would be the area under the graph. The area under the graph for, let's say, 0 to 14 seconds, it will actually tell you where is the distance traveled by the remote control car. Then the other thing that we want to take note is the gradient of the graph. Okay, the gradient, let's say for this case, for 0 to 10 seconds, you'll find that it's a positive gradient, which means that this will actually tell us the car is actually having an acceleration. On the other aspect, whereby you have 10 to 14 seconds, 10 to 14 seconds, same thing. You look at the gradient here, is telling us about the acceleration. The only difference is that this gradient here is negative. Okay, if it's negative gradient, it implies that the acceleration will be negative, or aka what we know as your deceleration. So when you look at kinematics, okay, the moment you have speed time graph, the approach is always the same. You look at the axis to make sure the units are what you need, then followed by you. Most likely the question will need you to find the gradient or find the acceleration, and sometimes maybe end up with like identifying the area under the graph or the distance traveled. Now, okay, with this in mind, right, then you look at the questions given. So true enough, you see, the question in part B, they ask for total distance. Okay, the time taken is 14 seconds. So basically, they're asking you to find the area under the graph. Okay, the area under the graph, which is the triangle. Okay, under the graph for 0 to 14 seconds, which is the area. So what you see here is a big, gigantic triangle. So same thing, if you know the whole, you just use the formula for triangle. So it'll be half base times height. Okay, remember, take note of the time, make sure it's in seconds. Then after that, based on this, based on the values that you have, you get the answer. Okay, the numbers, remember, all calculation in physics. Okay, leave it to 2SF. Okay, round it up to 2SF. Now, the part C that we are looking at is part C. Okay, based on your graph, explain the magnitude of the acceleration. Okay, the question is asking you to explain using the graph. So remember, your answer here is not just telling me the number or work out the number. Okay, based on the question is that you have to use the graph given. Okay, so if you work out a number but you don't make reference to the graph, okay, the marker will not give you the answer, the marked one. Okay, so what we mean by make reference to the graph is the concept that I mentioned above. Okay, the gradient, okay, from the graph, the gradient allow us to deduce the acceleration. So basically, when you want to compare the accelerations with respect to the graph, the question is actually asking you to make comments on the magnitude of the gradient. Okay, so that's why when you look at the magnitude of the acceleration, you have to make references to the gradient of the graph. So that's why you look at answer that are given to you. Although we can conclude the magnitude of the deceleration is bigger based on calculations, the answer or the keywords that I set at the end of the for your explanation is actually make references to the gradient. So you have to tell me that the deceleration, the magnitude is bigger than the acceleration. Why? Because the gradient of that line is actually steeper than the acceleration. Okay, so we make references to the gradient here because that is what the question is asking for. Okay, make references to the graph, not just give me a standard definition of or calculations of like you're calculating like your change in velocity thereby change in time. Okay, remember to make references to the graph. Now, then after that will be I would say it's a normal calculations for Newton's law. Okay, so all accelerations. Now, when we look at the net force, which means it requires us to use Newton's second law, F net equal to ma. So Fnet equal to MA, same thing. Okay, in this case, he is not just looking at Fnet yet. Okay, to calculate Fnet, you need the acceleration. Okay, between at 4 seconds. So basically, I need the gradient at that line. Okay, if you use the formula, okay, you can use the gradient formula, or you can use the acceleration formula, final minus initial, divided by change in time. So if you substitute the correct formula, you should get the answer to be 0.06 meter per second square. Then after that, remember, you don't just end here. The question need you to calculate the net force. So the next calculation you use Newton's law to calculate the net force, which is just MA lah. Okay. So now for 2 marks question, you find that it's always very, I will not say it's a very standard approach whereby you just do a one-step working, you can answer. Sometimes the question will actually require you to do like 2 steps calculation. First step, find the acceleration. Then after that, sub the formula into another formula to get the answer. Okay, so sometimes 2 marks doesn't mean it's a simple calculation. Sometimes it could be a simple calculation, but it's in terms of a series. Maybe it could be a one formula leading to another and leading to another. Okay, so check your working. Okay, see what the question is asking for. Now, so for question 5, right? Question 5 is EM spectrum. It's a combination of EM spectrum and your wave formula. Is it a common question in section B? Not really. Okay, usually EM section will come in section A, but it doesn't mean it cannot come out in section B, which also reinforces the fact that in your physics paper, even though it's a 50 marks paper, you literally need to study everything. Okay, you can't really spot a question to say that this particular EM spectrum, it will not come out. Okay, in fact, for this question, it actually come out as a main big part in your section B. So that's task is important to actually read, to revise every topic, to be thorough in your revision, okay, and to actually expect what the examiner expect you to do, okay, to be well versed in all your chapters. Now back to EM spectrum. EM spectrum, same thing. The gamma, the arrangement of the wave, okay, is a standard things that we need to know. Okay, the arrangement of the wave in terms of the frequency arrangements or in terms of the wavelength. Okay, so you will know that straight away. If I not know P, okay, wavelength P here will be your microwave, you should know, okay, because they ask for the application. So if the first card is to give me the correct application, you must know the wave that is of interest. Okay, in this case, it will be microwave, and you just throw in whatever application that you know. Now, the next question that you see is ultrasound versus wave Q, or what we call AKA, is a combination of a comparison of longitudinal wave versus your transverse wave. Okay, and this aspect is actually quite a common question, whereby we do a simple comparison between longitudinal and transverse wave, and the answer is actually quite standard one. Okay, for example, the difference between longitudinal and transverse wave is in terms of the speed, the magnitude of the speed, or it can be in terms of the medium. For example, longitudinal wave require a medium. Okay, you need a solid, liquid, or gas, but transverse wave actually can travel through vacuum. Okay, so the answer I would say is the answer when we talk about differences is usually around these 3 differences. The third differences will be the vibration. Okay, longitudinal wave, the vibration of molecules is actually parallel to the wave motion, as compared to transverse wave is perpendicular. So for this type of question, right, okay, the answer actually revolve around these 3 points. So if you know these 3 points, you just take any two, basically any two that is like shortest and more precise one. Okay, so this question, okay, you should be actually well versed in it, because it's very, very common in whether it's N level or O level. Okay, state the speed of radio wave, aka the speed of EM spectrum. Okay, EM spectrum wave is a standard number. Okay, speed of the EM wave is 3 times 10 to the power 8. Okay, this number, students, we have to know this number, because this is one of the 2 constants that we are supposed to memorize. First constant we need to know by heart is the field strength of Earth, 10 Newton per kg, followed by speed of light or EM wave or transverse wave, which is 3 times 10 to the power 8. Then after that, the last part, I think, it's the last part. Okay, no, second last part. Okay, the second last part, the question look at the wave formula, V equal F lambda. Same thing, I will not say is difficult here, but the trick that they trying to push to you, it would be the use of prefixes. Okay, chapter 1. Chapter 1 is the simplest topic, but it doesn't mean it will not come out. For this case, you see, the question come up with 100 nanometer. So you must know what the heck is nanometer. Nanometer is, nano means times 10 to the power minus 9. So you must know the prefixes. Okay, so in this case, right, for nanometer, 100 nanometer, it actually means 100 times 10 to the power minus 9 meter. Remember, in the formula for physics, all the formulas require students to actually pump in the values in SI unit, not anyhow any unit I give you. For example, in the previous question, we look at kinematics. The moment I look for time, you must be prepared to actually convert whatever time I give you to make sure it is in seconds. Distance, it could be km, convert it to meter. So that's where we have your SI units. So once you are okay with conversion, you must be okay. Once you're aware that you need to convert, you find that your frequency, your lambda will be 100 times 10 to the power minus 9. Your speed will be 3 times 10 to the power 8. After that, let your calculation do the work. You should get the answer straight away to be frequency 3 times 10 to the power 15. Now, here I make a mistake here. In my answer, I write 3 times 10 to the power 8. Is the exact answer that I see from the calculator. But take note, because we expect all answer to be in 2SF, maximum we give you the leeway is 3SF. So if you write 3 times 10 to the power 10, 15, right? This number here is in 1SF. So you must make effort to write a 3.0 times 10 to the power 15. Okay, you can write in terms of standard form, 3.0. Remember that 0.0 here, 2SF. Or you can just ignore the standard form, just write, give me 15 0 behind. Okay, which is also okay. So 3, then you write me 15 0. Wow, that's a long zero. Okay, we also accept. Okay, because there is also a way of representing it in terms of 2SF. Last part here will be the wave structure. Okay, sketch a sound that is twice the pitch, double the loudness. As wave, okay, when we talk about wave in terms of pitch and loudness, remember, pitch refer to the frequency. Higher the pitch, higher the frequency. Loudness refer to the amplitude of the wave. Okay. So what we have is twice the pitch. Now, twice the pitch, twice the frequency. So let's say if AKA means the frequency actually double. But remember, on the wave graph, right? On the wave graph, you actually cannot, I would say you cannot draw frequency straight away, because in the wave graph, what you see directly is what we call the time. Time and frequency, they are related because they are inverse. So when we say frequency double, okay, we are actually literally saying that the period of the wave actually is being half. Okay, so actually when we say pitch double, or the pitch double, frequency double, okay, the wavelength, the time, the period for the wave actually becomes shorter. So it's what we call the wave actually shrink a bit. So what we need to draw on the new wave is you should be a new wave whereby the period is half of the period of the current one. The amplitude is actually double. Okay, so let's say if wave P is given there, one period is 4 big square, the existing one. So I'm looking at the new wave should be actually half of the original period, which should be 2 square only. Amplitude wise is actually double. So now the amplitude for the new wave, the old wave is here, 1 square here. So double means the amplitude of the new wave should be actually be 2 square. Okay, so the new wave is double the amplitude, half the frequency. Okay, so it will look something like this. Okay, so now the common question that students will ask is, how many waves do I need to draw? Okay, usually my advice to students will be actually like draw back what is given. For example, on the original wave, right, the graph actually, the marker actually give us 1.5 cycle. So my advice is actually draw back the same amount of cycle. You can draw more, okay, but you just drawing back the same one, I think is good enough already. So this is 1 cycle. Then maximum, maybe I will draw 1.5 cycle here. So I will complete the wave here. Okay, so I will just pack as per the what marker is given. So if the marker give me a 2 cycle wave, I will just draw back a 2 cycle wave. Okay, unless the question says, right, complete the wave to a certain timing, or the questions specifically asked to draw maybe 4 cycle or 2 cycle or 1 cycle. So then you draw accordingly. So it depends on the question now. Okay, so take note of the wave that is given. The last question here, look at practical electricity. Practical electricity is a common question. Okay, it's quite a hot topic when we look at physics. Okay, same thing. We have, based on the question, 240 volts, washing machine, electrical kettle. Remember, they are connected in parallel. Now, same thing, when the moment you see them in parallel arrangements, okay, the common things, the one and only advantage that we have in parallel circuit, the most common one is that parallel circuit allows components to operate independently. So which means when one of the appliances is not functioning or the appliance is not switched off, the other appliances can still continue to work. This is the most common advantage, okay, that we have in the parallel arrangement. So of course, students, you need to take note, like we have to take note of what of this arrangement, because this is very common when we ask for advantages. Now, the current flowing through the washing machine when you switch on, now, given the washing machine here, washing is 240 in parallel. So effectively, the potential difference across the washing machine is also 240 volts. Kettle will also be 240 volts. Okay, and you given the power of both appliances. So straight away, you can use your power formula, power equal to IV. So you know the kettle, the washing machine is 1,400 watts. Your potential difference is 240. Then after you can find your current straight away. So 5.83, that's your current for the washing machine. So it should be something like this. So the current here should be 5.83 for the washing machine. Okay, so after that, what you do, okay, if fuse X is 10 M, so fuse X, so you must know where is fuse X. So you look at the symbol on top. Okay, fuse X is a rectangular box with a line straight through. This is a symbol for the fuse. Okay, fuse, you take note, fuse is on the live cable and it's actually on the main cable. So when we talk about fuse, the current going through the fuse, I label it as I total. It actually consists of two current. It consists of the sorry, it consists of the current in the washing machine plus the current in the kettle. Okay, so to check the fuse rating, to check whether your current rating is suitable or not, right? First thing first is you cannot just take 5.83 because it consists, the main current flowing through fuse, is I total. I total, I mentioned, it consists of the washing machine plus the kettle. So you need to know the current of the kettle. So what you do is you repeat part B again for kettle. And true enough, you will be able to find that the kettle current is 5.83. This is the kettle, and the washing machine is 5.83. So if you combine these two, you'll find that the current flowing through the main cable is 9.16. Okay, 9.16 is actually less than 10 M. So same thing, you must know how the fuse work. Okay, remember fuse work, actually fuse will only start to melt when the current is actually at 10 M or above. So if your working current is 9.16, definitely the fuse will not be activated, and it will means that the fuse is actually suitable for that circuit. Okay, so take note of the convention. Okay, so end of the day, 10 amp fuse is actually suitable for the fuse for this circuit because the rating is actually slightly above the operating current, which is good. Okay. Now for earth wire here, earth wire is to protect the user. It's in contact with the metal casing. So these are the keywords. If you are supposed to write for earth wire, remember keywords: live wire touches metal casing. Okay, so explain how it works. Okay, this is a classic example or classic answer question when we talk about explaining the precaution. Explain how fuse work, explain how earth wire works, explain how the switches work. Okay, and even explain how does double insulation work. So all these 6 precautions, we have to know how they work, how they function, and most importantly, what are the keywords tagged to them. Okay, so same thing, how does the earth wire works? Okay, earth wire, remember, it allows when the live wire touches the metal casing, what it does is the earth wire will actually allows the current to flow through it. And why we say earth wire and what constitutes earth wire? Earth wire is just a path of low resistance. So in your answer, remember in the keywords, you have to mention what is earth wire. So you have to mention it is a path of low resistance. So what it does, it actually allows current to flow through it. Okay, so that would be the example. That would be the keywords for earth wire. Okay, but take note, what is different in this question is that the circuit actually has a fuse inside. So which means your questions that we need, right? When we explain how does earth wire works, once earth wire is activated, current flow through the earth wire. Okay, but it doesn't end here because your circuit has a fuse. So when the current flow through the kettle down to the earth, okay, that current, okay, essentially will actually activate the fuse also. Okay, because what happened? Because the current flowing through the earth wire, okay, although it's flowing through the earth wire, but because it's a low resistance path, the current in the circuit, the current flowing through the circuit, flowing through the earth wire now is actually a big current. Okay, why? Because of the low resistance path, low resistance, high current. So what will happen is that the fuse will be activated, and as a result, the fuse will melt or will blow, and thus create an open circuit, and that will protect the user. Now, in this case, right, how do we know? How do we know we need to write? How do we need to know we need to write what happened to the fuse? I would say the clue here would be that the question say, how does it protect the user? Remember when earth wire is activated, right? Earth wire allows current to flow through the metal casing down to the earth, which means the current is actually still live. The circuit is still live. Current is constantly flowing through the earth wire down to the casing. So which means essentially there is still a risk that when a person touch it, he or she may actually be electrocuted. Okay, may not die, but there will be electrocution. So the protection for the user is still not 100%. So when you talk about protection, okay, it actually will hint to students who say that it is actually 100% protection. You have to actually eliminate the leakage current. So this is the clue whereby it tells me that I have to write, or I have to make sure that the leakage current actually disappear. Okay, so when we talk about protection, okay, it means the leakage current will actually disappear, okay, or eliminated. So to be eliminated, okay, or to disappear, the only way to disappear is your fuse has to be activated. So that would be a clue for me to actually write down that the fuse will be activated, the fuse will melt. But of course, will I be able to write fuse? If you ask me, right, I will say my first take is I will actually stop at earth wire. I actually will not write fuse. Okay, so same, like, I would say no difference. If you happen to just miss out the fuse, I would say it's not your fault, but just take note of it. Just pack it inside your database, okay, your revision tools, to make sure that if the question does include a fuse, always remember to link it to the fuse. Last question, 5E, okay, calculation of the cost of electricity. Same thing, when we talk about cost of electricity, we are looking at the energy first. I need to calculate the total energy first. So the approach is always the same. I need to calculate the total energy used. Then after that, I use it to calculate the cost. Okay, and same thing, the moment we talk about energy use, the energy here we're talking about, it has to be in kilowatt hour. So which means that the power I'm referring to, so the power that I have to use, usually when you calculate kilowatt hour, power has to be in kilowatts. Your timing has to be in terms of hour. This is the only formula in your entire 2 years of N level, right? It doesn't require SI unit. Okay, so this is something that we have to take note. Okay, when we talk about electricity, we talk about energy, we talk about costing. So when we talk about energy, right, the energy unit we're looking at is kilowatt hour, which means your energy formula, PT, your power and the time. In this case, it has to be a non-SI unit. It has to be specifically kilowatt, and it has to be in hour. So in the question here, they say 1.5 hour, 0.5 hour for kettle. Here, for this question, right, do not change the hour to second. Okay, because this formula requires us to have a so-called certain unit, time to be hour, power to be in kilowatts. So same thing, given your washing machine is 1,400 watts, you convert it to kilowatt hour first, okay, which is 1.4 kilowatt, sorry. Then after that, same thing, your kettle, 800 watts, change it to kilowatt will be 0.80 kilowatts. Okay, time 1.5, nothing major, just leave it there. 0.5, just leave it there. The other additional thing we take note is the question asked for 1 week. 1 week is 7 days, so you must remember times 7, multiply by 7. Okay, that will give you the total energy given. Then after that, you look at the cost. 1 unit is 20 cents. You multiplying the cost, the ratio, you get the final costing to be 350. Okay, it's a standard procedure or a standard method that we look. look at. So if you look at this question, right, whether it's question 4, 5, 6, okay, out of these 3 questions, right, I'm supposed to choose 2 questions that will actually give me the best or the most marks. Okay, so if you ask me, right, 4, 5, 6, I will definitely choose question 4, which is a kinematics question, which is fairly straightforward, I would say. Question 5 and question 6, right, I will actually choose question 5, okay, because 5, the questions, answers, the calculation is actually very straightforward and there's no booby trap. Okay, 6, because of the question D, the fuse rating, the fuse and the earth wire, I may not be confident of getting that 1 mark. So if you look at the 2 questions that I chose, right, the 2 questions I chose is not because I like that topic. It's because the 2 questions that I chose is because it allows me to get the most marks. Okay, so for section B, remember 3 questions, choose 2, right? You have to choose the correct 2 questions that will value add your marks. Okay, to have advantage to you. Okay, so choose the 2 questions that give you the most mark. Okay. So if not, okay, this is where I end off, okay, for this particular paper. Okay, so same thing. If you need anything or if I've done anything, if I explain anything wrongly, leave a comment in the description bar below, okay, and just let me know. Okay, if not, bye bye.